Have you ever wondered what it would be like to travel through time? This tantalizing question has captured the human imagination for centuries. From H.G. Wells' The Time Machine to the iconic DeLorean in Back to the Future, pop culture is brimming with examples of our collective fascination with time travel. But what is time, really? Albert Einstein proposed that time is a fourth dimension, intertwined with space in his theory of relativity. This concept, mind-boggling as it is, brings us one step closer to understanding time travel. However, the idea is riddled with paradoxes. What if you traveled back in time and changed something? Would that alter the future? These are the challenges that make time travel such an enigma. It's a tantalizing puzzle, a captivating mystery that continues to baffle the brightest minds in science. So, if time travel is so complicated and full of paradoxes, how can it even be possible? Scientists have been playing with the idea of time travel for a long time. The concept, as fantastical as it may seem, is deeply rooted in science, particularly in the realm of theoretical physics. Let's start with one of the most famous theories in the world of physics, Albert Einstein's theory of relativity. According to this groundbreaking theory, time and space are interwoven into a single continuum known as space-time. But here's the twist: space-time isn't a flat canvas. It's more like a fabric that can be stretched and curved by the objects with mass. The heavier the object, the more it distorts space-time. This phenomenon is what we perceive as gravity. Now, how does this relate to time travel? Well, Einstein's theory also proposes that time isn't absolute. It's relative, meaning it can be influenced by gravity and speed. Theoretically, if one were to travel at near light speeds or venture near a massive object, time would slow down for them relative to someone in a different, less curved part of space-time. This is what we call time dilation, a concept that, while mind-boggling, has been proven by numerous experiments. Then there's the concept of wormholes. These are theoretical passages through space-time that could create shortcuts for long journeys across the universe. If they exist and can be stabilized, wormholes could allow us to travel not just through space, but also through time. However, it's crucial to remember that these theories are just that, theories. While they suggest that time travel could be theoretically possible, the practical application is a whole different beast. We're still grappling with countless questions. How can we harness enough energy to distort space-time or stabilize a wormhole? What about the paradoxes that could arise from time travel? But even though time travel might be theoretically possible, we're still a long way from making it a reality. Time travel isn't just about finding a way to move through time. One of the most significant challenges is the sheer amount of energy required. Even with the most optimistic scientific theories, we're talking about energy levels on par with that produced by a star. Harnessing such energy, let alone controlling it, is far beyond our current technological capabilities. Then there's the risk of creating paradoxes. The classic example is the grandfather paradox, which poses the question: if you travel back in time and accidentally prevent your grandparents from meeting, then you would never be born. But if you were never born, then how could you have traveled back in time in the first place? It's a mind-bending concept that challenges our fundamental understanding of cause and effect. Some theories suggest that paradoxes could be avoided by the existence of multiple timelines or parallel universes. But even if these theories are correct, we're still left with the question of how one might navigate through these multiple realities without ending up lost in time. And finally, we must consider the potential for catastrophic consequences. What if, in our attempts to manipulate time, we inadvertently cause damage to the fabric of space-time itself? This could lead to a host of unforeseen and potentially disastrous outcomes, such as the creation of black holes or the destabilization of our universe. It's important to remember that these are not just theoretical concerns. Every time we make an advancement in our understanding of the universe, we open up new possibilities, but also new risks. For example, when we discovered nuclear fission, we gained a new source of energy, but we also created the potential for nuclear weapons and nuclear accidents. So, time travel isn't just a scientific challenge, it's an ethical one as well. We must weigh the potential benefits against the potential dangers and ensure that our pursuit of knowledge doesn't lead us down a path of self-destruction. These challenges might seem insurmountable, but that hasn't stopped scientists from trying to tackle them. So where does that leave us with time travel? Well, the future of time travel, like many frontiers of science, is shrouded in mystery and brimming with possibilities. As we continue to probe the depths of the universe, we are making fascinating discoveries that could pave the way for future breakthroughs in this field. At the forefront of this exploration is quantum physics. With its mind-bending theories of entanglement and superposition, it's like a treasure chest filled with keys that might unlock the secrets of time travel. Quantum physics has already shown us that particles can exist in multiple places at once. Could this be a stepping stone towards realizing time travel? And let's not forget about wormholes. These theoretical tunnels through space-time, if they exist, could serve as shortcuts across vast distances and perhaps even through time itself. Scientists are striving to understand the nature of these mysterious phenomena and how they might be harnessed. But time travel isn't just about the science. It's also about the implications it could have on our society and our understanding of reality. If we could revisit the past or glimpse the future, how would that change our perceptions of time and space? How would it affect our decision-making, our ethics, our sense of self? These are profound questions that we must grapple with as we venture further into this uncharted territory. On the flip side, time travel could also pose serious risks. Paradoxes, disruptions in the space-time continuum, the potential for misuse. These are just a few of the dangers that could come with such powerful technology. It's a double-edged sword that we must handle with great care. The future of time travel is thus a thrilling yet daunting prospect. It's a journey into the unknown, filled with immense challenges and tantalizing rewards. As we push the boundaries of our knowledge and technology, we're writing the next chapter in the epic tale of human discovery. Whether we'll ever be able to travel through time is still uncertain, but one thing is clear: the journey to find out is going to be fascinating. To sum it all up, we've journeyed through the concept of time travel, delved into the scientific theories that hint at its possibility, and confronted the challenges that come with it. We've also peeked into the future, exploring the ongoing research that keeps this fascinating field alive. Time travel remains a captivating concept that continues to intrigue scientists and laymen alike. Perhaps one day we'll find a way to make it a reality. Until then, we can only imagine what it would be like to journey through time.